Welcome to the demo of Customer Churn Prediction app developed by eCube Analytics. First, what is customer churn? Every business has customers, and if the business keeps the data of the customers, then on the basis of past data, it is easy to predict which customers are planning to switch to your competitor. This particular app is for banking sector, but similar analysis can be done for any business. So let us start with the business problem. This is the data set. This is 10,000 rows and around 14, 15 features for a multinational bank. You can see the geography: France, Spain, Germany. So there are clients from multiple different countries. Now, gender, age, tenure, balance, number of products. Number of products here means whether the customer has only one saving account than one product, but customer may have saving account plus personal loan account plus maybe housing loan account, then three products, and so on. So we want to see whether kind of taking a customer in the fold of our various different services reduces the tendency of the customer to go to our competitors. Then there is another: has credit card or not, is active member or not. Again, is active member is defined bank to bank in a different manner. One bank defines that if a customer does not transact for 3 months, is inactive, but another bank may define that he does not transact for 6 months, is inactive. So this is the data for that customer, estimated salary, and this is exited or not exited. This is already past data, so we already know that this customer has churned, went to some competitor bank. This customer did not churn. This customer churned. So now we want to understand this data, and on the basis of this data, we want to create a model that can be used to predict in advance the behavior, that is likelihood or probability of churning for some customer for whom obviously this label column would not be there. Okay, so for that unknown data only this columns would be there. This geography, gender, etc., this one row, this is called feature vector. So on the basis of feature vector, we want to predict the outcome. This is just a demo video of the final product which is deployed on a cloud. Therefore, we will not go into entire data science portion because this is not a data science tutorial, but I have included this in my tutorial series. So if some of you are interested, you can please visit that tutorial series at ecubeacademy.org. Now here you can see that when you see the final product, it will be completely different with a nice user interface and everything, but a lot of hard work is involved by the data scientist in the background. This is in the Jupyter notebook, and finally the table is created here. I mean, model is created here, and the model is saved. Okay, and on the basis of that model, you are creating probability of churning based on certain threshold. That if probability is greater than say 70%, then that customer is more likely to churn, and we want to find a list of all these customers who are more likely to churn, and then we want to do some more things also. For example, we want to do analysis of that churn, that is which feature is responsible for analysis as a whole on the data. So that means, for example, this credit score is there, then credit score we will bin into various groups. Say credit score from 300 to 600, then 600 to 800, or maybe 300 to 400, 400 to 500, 500 to 600, like that. And we will see that whether that to which bin or to which group the customer's credit score falls, does that affect his probability of churning to the competitive bank? Okay. Similarly, we will bin gender into parts male and female, we'll bin age into say 18 to 28, 28 to 38, 38 to 48, like that. And we'll see tenure means how long is the association of the customer with the bank, and so on. Now, with that, if you want, we can first, this is the code in a script form, and this is useful for data pre-processing, feature engineering and all. But such code cannot be deployed. Here we created a model, and final churn model F1 0 underscore 53. So actually this is the model for which is optimized for the best F1 score, and 53 is the threshold which was used for that model to decide that what is the boundary line at which the customer will churn. Okay, this 53 can be decided by the bank depending upon his its preference, but then the whole new model will be required for doing that. Or you can design your app in such a manner that it dynamically creates new model based on some threshold which is entered by the user in the user interface. Such an app will be more useful, because if bank is passing through say high churn period where a lot of customers are churning, then the bank may reduce the threshold and the bank may aggressively go for churn prevention. So bank may tell the data scientist that give me a list of high churn probability, uh, taking threshold of only zero point 0.4, that is anybody who is having only just 40% probability, give me them also as probable churners. Okay, and then we will offer some discounts to them, and we will try to prevent them from going to our competitors. But sometimes when the bank is comfortable in the customer base and does not want to spend resources on offering discounts unnecessarily, then it can choose the higher probability, maybe zero point 0.7. So that means bank is telling that give me only those customers which have more than 70% of the probability. Okay. Now this is actually the rough work in the Jupyter notebook, but you can see that we have created a whole data science pipeline, and we tried different algorithms, and finally we saved the best possible model with the best possible hyperparameters. Okay, so Jupyter notebook is useful for understanding the data pre-processing and feature engineering. But once it is done and your model is saved, then you can switch to some IDEs like maybe VS Code or PyCharm, which provide uh, uh, modular code development. Even Jupyter Lab also can allow modular code development. I have used PyCharm. So you can see here is that model which we created by Jupyter Lab, and here are various files. Now you see that various logics have been separated. So some pre-processing is done by this Python script, some analyze churn is done by this Python script, then This is the basic app.py which generates the first user interface. I have actually run this app.py and my app is at present running on my local host. Its a more modified and improved version was deployed on a cloud, but that is a different story. And this is shapeanalysis.py. We will see what is shape analysis. Okay, so such modular code helps. Templates include the user interface pages, HTML, index, result page HTML, and shape.html. And in the static, there is a scripts folder where JavaScript, which handles the communication between front end and back end, that was developed. So this is how a modular code is developed, and the modular code helps in reproducibility, it helps in maintainability, and it helps in understanding the code as per the functionality of the app. Once this app is run, that is here, I can click this link on the port 5000, then it will open this particular. Now let us see, I have already said that upload the data with following features. If you see the last feature is estimated salary, that means that exited the response variable, whether the customer has churned or not, that is not to be taken. That is unknown. We want to test our data. So upload this xtest.csv file. Here is my xtest.csv file and I upload that, and you can see that that file is populated and 999 observations are there, more than enough for testing our model. Here I can choose some threshold. I am keeping zero point 0.7 and I am developing high churn list. So these are all the customers who have more than 70% probability of going to competitor bank. So bank must offer them some discount, some offer, maybe some lower rate loans, or maybe other things. Bank may send its relationship manager to call them and ask them that why are you not uh, what, are you having any problem with our bank's services and so on. You can even analyze this high churn list. That analyze means which feature like credit score, what is its effect on this high churn list. All these are likely to uh, churn, but the question is which feature is responsible for churning. So I can click analyze high churn list and a new plot is created here, and these are the bins in the credit score. So you can see the red colored is mean probability of churning and blue color is median probability of churning. So uh, 370 to 450, 450 to 530, 530 to 610, and so on up to last credit score bin is 770 to 850. And you can see mean and median probability more or less are same, but some people prefer median for interpretation because of some statistical reasons. So I have given both on the dashboard. Now you can see that in the lower credit rate bin, credit score 370 to 450, the probability of churning is quite high. But in this bin, for example, 690 to 770, the probability of churning is only 0.83, 0.82. Of course, all these are high churn lists, so all they have probability more than 70%, and all these are likely to churn. That is a different matter. But among them also, which credit score bin is more vulnerable to churn? Then geography, that is France, Germany, and Spain. For in Indian context, this can be various states of the country, or it can be maybe zones of the country: western zone, eastern zone, northern zone, and southern zone. Whole country can be divided into four parts like that. Gender, so whether females are more likely to churn or males are more likely to churn, like that. Age, age is divided into various age groups. 18 to 28, 28 to 38, and you can see highest probability of churning comes somewhere here, maybe 0.88 and 0.89 probability in this range, that is 48 to 58. Here also it is the same, 58 to 68, while low probability is in maybe 28 to 38. So we can study the effect of various factors. Has credit card or does not have credit card seems to be affecting not much. Then number of products. Then you can see one product people have low probability. Three product people have highest probability, median and mean, and so on. And is active member. Then if person is a not active member, zero, then usually the probability of churning is higher compared to person who is regularly doing transactions. Okay, and estimated salary. So this is how various effects can be seen. Now we come to another part. This is SHAP analysis. This time we don't want to upload the test file without the label, but I am deliberately uploading the whole data set, including the label file exceeded or not. So now my aim is not to predict the churn probability, but now my aim is to understand the behavior of each and every customer, that okay, customer X and customer Y both are churning, that is fine, but for customer X, the factors which led to churn, that are different compared to customer Y, the factors which led to churn. But at the on the other side, if customer A and B both did not churn, but again the factors which caused that non-churning behavior or staying loyal to the bank, that behavior, that are different for customer A compared to customer B. So let us upload our file high churn list dot not sorry not high churn list, our original data set with 10,000 rows. We started in Jupyter Notebook with this data set. We did extensive feature engineering, we did data cleaning and all that, and finally we developed the model. So here this exited column is already there. So this first customer ID only has churned, and the second customer ID has not churned. Our aim is to understand why first has churned, or which factors have contributed to his churning, and why second has not churned, or which factors contributed to his non-churning behavior. That is done by what is called SHAP plot or SHAP analysis. So I put the customer ID and I do this SHAP analysis, and you can see such plot is generated. First customer had churning behavior, then how to interpret the SHAP plot, then all features which are red, they are pushing the prediction towards 1 churned, and all blue features are prediction pushing the prediction towards 0 non churned. Obviously here the customer had churned, so red features are very long band, while blue features have very small band. In the red also, which factors are responsible for causing the churn? Then surname. Now surname is usually removed from the model. Here it was kept because this is just a demo project. But number of products is 1. So those customers who had only one product, say plain vanilla saving account, they are more likely to churn. And the reason is also clear that the reason is clear that that customers can easily start banking with other banks just by closing one account, and that is the reason why bank salesmen or managers go on pitching you to buy another product. If you have saving account, they will ask you to buy one car loan account, that is take one personal loan, so a personal loan account, car loan account, then maybe another insurance and many other things, because more the products, then more difficult it is or inconvenient it is to sign multiple forms and close various accounts. So that number of products here is only one, and that customer is likely to churn. Gender is zero, female. That is also responsible. Age 42, and balance per product is zero. So this customer is having only one product and keeping no balance, zero balance product. So such customer is highly likely to churn. But now do shape analysis for a customer who did not churn. That is this second customer, exited is equal to zero. Then you will see that we can do the shape analysis, and this time blue colored band is longer, so he did not churn. Is active member, then this time it is 1, here it was okay, it was not there. Then balance per product is very high, there it was 0, while here balance per product is 83,000 somewhere, because it is exponential 4. Okay, so is active member means the person is frequently doing transaction, keeping high balance per product, and he is not from Germany, then such a customer is more likely to churn. So this is a app. Now our bank can deploy such apps, and sometimes like maybe ICICI Bank or highly tech savvy other banks, they have already deployed such apps, and they are continuously monitoring customers' data and analyzing them, so that they don't lose a customer. They can prevent the customer even before the customer shows churning behavior. So this is a nice example of predictive